A prefab guard booth within a commercial building is considered a structure within a structure. A grounding electrode conductor, often referred to as a GEC, is typically not required for a prefab guard booth installed inside a commercial building because it is not a detached building or structure. The requirements pertaining to grounding electrode conductors are detailed in Article 250.32 of the National Electrical Code, often referred to as the NEC. However, if the guard booth is constructed on site as a small room, it is then considered a permanent part of the building according to the NEC and must adhere to all applicable grounding requirements, including the installation of a grounding electrode conductor. Article 545.12 of the NEC applies to electrical equipment installed in parking garages and mandates that all electrical equipment must be grounded in accordance with Article 250, although it does not specifically address prefab guard booths. In summary, a grounding electrode conductor is generally not needed for a prefab guard booth inside a commercial building. A grounding electrode conductor would be necessary if the guard booth is constructed on site as a permanent room. The feeder to the booth is 50 amps at 120/208 volts. Article 250 provides comprehensive guidelines for grounding and bonding electrical systems to ensure safety. Grounding creates a low impedance path for fault current, which helps to trip over current protection devices like circuit breakers or fuses, thereby minimizing the risk of electrical shock and fire. Bonding, on the other hand, connects non-current carrying metal parts of electrical equipment to create an electrically conductive path. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. The grounding electrode conductor connects the building's grounding system to a grounding electrode, such as a ground rod, metal water pipe, or ground ring. For a prefabricated structure, since it's within another building, it's considered part of the building's overall grounding system. This means that the grounding of the prefab booth is achieved through the building's existing grounding system. The metal parts of the prefab booth that are likely to become energized must be bonded to the building's grounding system. This can be achieved by connecting a bonding conductor from the booth's metal frame to the building's grounding electrode system. The size of this bonding conductor is determined by NEC Table 250.102. If the guard booth were built on site, it would be considered a permanent part of the building and would need to adhere to all applicable grounding requirements, including the installation of a grounding electrode conductor. In that case, the grounding electrode conductor would need to be connected to a grounding electrode system, such as a ground rod, metal water pipe, or ground ring. The size of the grounding electrode conductor would be determined by NEC Table 250.66. Article 545 addresses manufactured buildings. However, in this case, it's more relevant to consider Article 250 for grounding and bonding requirements and Article 408 for the panel board requirements inside the guard booth. Understanding these articles is essential for ensuring electrical safety and code compliance in commercial buildings. It is crucial to consult with a qualified electrician to determine the specific grounding and bonding requirements for your installation. Firstly, Article 250 covers the general requirements for grounding and bonding of electrical systems. Secondly, Article 408 covers the requirements for panel boards, including their installation and wiring. Thirdly, Article 545 addresses manufactured buildings and electrical systems within. Article 250.32 specifically addresses grounding requirements for separate buildings or structures, which is not the case for a prefab guard booth located inside another building. The general rule outlined in 250.32 requires a grounding electrode system at each separate building or structure supplied by a feeder or branch circuit. However, an exception exists if certain conditions are met, such as having a grounding conductor run with the supply to the separate structure and meeting specific requirements related to the connection of the grounded conductor. In the case of a prefab guard booth, the exception to 250.32 is typically applicable because the booth is not a separate structure in the same sense as a detached building. The grounding conductor within the feeder supplying the booth serves as the grounding means, and a separate grounding electrode system at the booth is usually not required. The appropriate size for the equipment grounding conductor within the 50 amp feeder is found in NEC Table 250.122. The size is based on the rating of the overcurrent protective device protecting the feeder. The purpose of the equipment grounding conductor is to provide a low impedance path for fault current to return to the source, thereby facilitating the operation of the overcurrent protective device. In addition to the equipment grounding conductor, it is essential to ensure that all metal parts of the guard booth that are likely to become energized are properly bonded together. This bonding ensures that all metal parts are at the same electrical potential, minimizing the risk of electric shock. The bonding connection should be made using methods that comply with NEC Article 250, Part VI, which covers bonding requirements. If the guard booth is constructed on site as a permanent room, it would be subject to the full requirements of the NEC for grounding and bonding, including the possible need for a grounding electrode conductor as per 250.32 if it were considered a separate structure under the code. In such a case, the grounding electrode conductor would connect to a grounding electrode system, such as a ground rod, metal water pipe, or ground ring. The size of the grounding electrode conductor would be determined by NEC Table 250.66 based on the size of the service entrance conductors or the equivalent size of the feeder conductors supplying the building. If the guard booth contains a panel board, the panel board must be installed and wired in accordance with NEC Article 408. This includes proper labeling, overcurrent protection, and wiring methods. The panel board should be readily accessible and not located in a hazardous location. The overcurrent protective devices in the panel board must be of the correct type and rating for the circuits they protect. It is important to ensure that all wiring connections are made properly and that all equipment is securely mounted. Furthermore, the panel board must be properly grounded and bonded to the building's grounding system. This grounding and bonding is essential for ensuring electrical safety and preventing electric shock. When installing electrical equipment in a parking garage, it is important to be aware of the specific requirements of NEC Article 511 and 514 as applicable. These articles address the unique hazards associated with parking garages, such as the presence of flammable vapors and the potential for physical damage to electrical equipment. Article 511 covers commercial garages, repair and storage areas, while Article 514 covers gasoline dispensing and service stations. These articles may require the use of explosion-proof equipment or other special precautions to minimize the risk of fire or explosion. In addition, electrical equipment in parking garages must be protected from physical damage. This can be achieved by using rigid metal conduit or other suitable raceways to protect wiring and by locating equipment in areas where it is not likely to be damaged by vehicles or other objects. If the guard booth is located in a damp or wet location, it is important to use equipment that is listed for use in such locations. This equipment is designed to withstand the corrosive effects of moisture and to prevent water from entering the equipment and causing electrical hazards. In addition, wiring methods used in damp or wet locations must be suitable for those conditions. For example, conductors must be insulated with a moisture-resistant insulation, and raceways must be sealed to prevent water from entering. A 50 amp feeder at 120/208 volts indicates a three-phase power supply. This type of supply is common in commercial buildings. It is important to ensure that the electrical system is properly designed and installed to handle the load imposed by the guard booth. This includes ensuring that the feeder conductors are of the correct size and ampacity, that the overcurrent protective devices are of the correct type and rating, and that the grounding and bonding system is properly installed. Before commencing any electrical work, it is essential to obtain all necessary permits and approvals from the local authorities. This ensures that the work is performed in accordance with the applicable codes and regulations and that the installation is safe and compliant. Furthermore, it is important to have the electrical work inspected by a qualified electrical inspector to verify that it meets all applicable requirements. In summary, determining whether a grounding electrode conductor is required for a prefab guard booth within a commercial building depends on whether the booth is considered a separate structure under the NEC. If the booth is considered part of the building's electrical system and is supplied by a feeder with an equipment grounding conductor, a separate grounding electrode conductor is typically not required. However, if the booth is constructed on site as a permanent room, it may be subject to the full requirements of the NEC for grounding and bonding, including the possible need for a grounding electrode conductor. It is always best to consult with a qualified electrician or electrical inspector to determine the specific requirements for your installation. The equipment grounding conductor is critical for providing a low impedance path for fault current, thereby facilitating the operation of current protective devices and minimizing the risk of electrical shock. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, reducing the risk of electric shock. Compliance with the NEC is essential for ensuring electrical safety and preventing fires. Always consult with a qualified electrician to ensure that your electrical installations meet all applicable requirements. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. Always de-energize circuits before working on them, and use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Electrical safety is paramount, and it is important to take all necessary steps to ensure that your electrical installations are safe and compliant. Understanding the NEC and following its guidelines is essential for achieving this goal.